Okay, I want to give you sort of a bigger overview of what's happening with rational functions. So rational functions usually have asymptotes in two directions or more. So rational functions look like this, basically. And then depending on what the equation does, you can also have holes just about anywhere you want. Asymptotes and holes are referred to as discontinuities, which makes us mathematicians feel really smart. It basically means the places where the graph is not continuous. So we call them discontinuities. So don't let that word scare you. It just means what parts of the graph can you not plug in. So in this case, -2 would be a discontinuity. -7 would be a discontinuity. 3 and 0 are also discontinuities. But there are also horizontal asymptotes. So in this case, we have a horizontal asymptote at 0. So on this worksheet, not only are you going to have to identify the vertical asymptotes, which is easy. How do you tell if there's a vertical asymptote? An uncancelled x in the denominator. The root of an uncancelled factor in the denominator will tell you where the vertical asymptotes are. How do you tell where the holes are? A cancelled, the root of a cancelled factor is a hole. Okay, well, how do you figure out where horizontal asymptotes are? And it's actually really easy. Let's consider the graph. You don't need to write this down. Let's consider the graph 1 over x. Okay? A horizontal asymptote represents a numerical value that can't happen, a y value that can't happen. Looking at the graph, we know x is not allowed to be 0. Why not? Because if you plug 0 in there, you get undefined, which is infinity, or negative infinity, or something worse. Well, are there any numbers that y is not allowed to be? Well, if you look at the graph, which I just drew, is there any y value that can't happen? 0 can't happen. Why not? Okay, never touches the x-axis, but why can 1 over x, so 1 over x, will never equal 0? How come? There's a 1 in the numerator. So if I had a fraction, okay, a over b equals 0, when does that happen? When a is 0 and b is not 0, right? b is not allowed to be 0, then it would be undefined. But if a is 0, then this is true. Well, when is a equal to 0? Never. It can't happen. So when you're looking at a rational expression, let's say we had x to the third over 4x to the fifth. That's going to simplify into 1 over 4x squared. Okay? If there are more x's on bottom than on top, your horizontal asymptote is always at 0. Because when the x's cancel, you have no variation in the numerator. And there's no way for the top to equal 0. Okay, so we're going to look at 3 or 4 different versions of this. But notice, if the degree of the bottom is bigger than the degree of the top, when you divide out the x's, you're going to have no variation in the top, and your horizontal asymptote, HA is what we call it, is y equals 0. Now, that's true even if it doesn't cancel. For instance, x over x squared plus 2. Can I factor anything? No. Can I cancel anything? No. So this has a horizontal asymptote. Where is it? Well, you just check. Are there more x's in the bottom than there are on the top? Yes. So is there any way for this to equal 0 on the y-axis? No. So your HA is y equals 0. Well, what if there are just as many x's on top as there are on bottom? Well, let's consider it. 4x squared over 6. Let's do 2x squared. So we're going to end up with everything cancels but a 2, right? So that graph is simply this. So the horizontal asymptote in this case is itself, which is 2. Let's change it a little bit. Let's do 2x squared over x squared minus 9. So in this case, we have 2x squared over x minus 3 and x plus 3. So I go here. Oh, I'm in a graph. 2x squared divided by x squared minus 9. Watch what happens. You see the vertical asymptotes, the VAs, at plus and minus 3. Everybody get that? Where is the horizontal asymptote? It's at 2. So essentially what's happening is, as we get very, very large, so as x gets really big, if I start plugging in 1 million, for instance, does this 9 affect the problem much? 1 million squared minus 9. Should we even worry about the 9? Not really. What about 2 times 1 million squared? Well, on the edges of the graph, when I get really, really big or really, really small, everything goes away except these terms. So 2x squared over x squared simplifies down to 2, which means on the far right and the far left, the only thing that matters are the coefficients of those x squareds. And 2 on top and 1 on bottom divide to be 2. Okay? So if I had 6x to the third plus 7x minus 5 over 12x to the third plus 6x squared minus 1, where is the horizontal asymptote going to be? Well, we look at what happens to the graph when we plug in humongous numbers. If I start plugging in humongous numbers, is this 1 going to affect much? No. Is the 5 going to affect much? No. What about my 7x? Is 7x going to be relatively the same size as 6x to the third? Not if the numbers are huge. In the middle of the graph, it's going to make some changes. But if I start plugging in 10 billion, 10 billion to the third is so much bigger than 7 times 10 billion, I can forget about that too. Same thing with this. And basically, the whole problem simplifies down to 6/12, which is 1/2. So, if the degree of the bottom matches the degree of the top, your horizontal asymptote will be found at the ratio of the two coefficients. Does that make sense? So, if this was a 2, where is the HA? It's at 0 because this simplifies down to 1 over 2x. And anytime there's no variables in the top, the horizontal asymptote's always at 0. Okay, well what if that's a 3? Well then the x's cancel, and this tells me where the HA is. Well, what if the top is bigger than the bottom? So let's say we had 4x squared, and then none of this stuff matters when we're talking horizontal asymptotes. Divided by 2x, and then some other stuff. Well, when that simplifies down, what am I left with? 2x. What does the graph of 2x look like? It's a straight line, and that is the asymptote. It's a slanted asymptote. So if I were to graph 4x squared, oops, let me clear that out, 4x squared, and I divide it by 2x, oops, you got to make sure you put parentheses. Let's see if this graph is any good. Okay, we got to add some other stuff on the side, or it's not going to like me very much. Okay, now it's not going to cancel as well. So it's a little bit hard to see, but the graph looks like this. It comes up and then drops off, and then it comes down and goes up. And this is the asymptote. We're no longer approaching a point. We're approaching the graph of a line. So this is going to get closer and closer to that line, and this is going to get closer and closer to that line. Okay, what if I went in and I got rid of the 2? How is that going to change the graph? Oh, wait. No, let's change that to a 3. Sorry, I went the wrong direction. That's going to simplify down to 2x squared, and the graph of 2x squared becomes an asymptote. So it's a parabolic asymptote. Now, you're not going to see that in here. Okay? So vertical asymptotes are super easy. Just check to see where the denominator equals 0 and the factor doesn't cancel. Horizontal asymptotes are more confusing. If the degree of the bottom is bigger than the degree of the top, then the horizontal asymptote is at 0. If the degree of the bottom matches the degree of the top, you divide the coefficients, and that is the horizontal asymptote. If the degree of the top is bigger, then you have a slanted asymptote or a parabolic asymptote or an x to the third asymptote, and so on. Okay? So, one more thing to consider. Where do these graphs hit the x-axis? Well, let's consider x minus 1, x plus 2, x minus 3, and x minus 1. First off, let's put a 12 here and a 4 here. Does this have any holes? Where? So x is not allowed to equal 1 because it's a hole. Does this have any vertical asymptotes? So we'll call it a vertical asymptote at x equals 3. Or, I mean, you can, either way, whether you put equal to or not equal to, I don't really care. Okay. Does this have a horizontal asymptote? Well, it only has a horizontal asymptote if there are more or equal x's in the bottom as there are in the top. How many are in the top? The top is x squared, and the bottom is x squared. So if they match, how do you find where the asymptote is? It's the ratio of the coefficients. So the horizontal asymptote is up here at 3. And then we have a vertical asymptote over here at 3. Okay. Now, where does the graph hit the x-axis? Essentially, we want to know, where does the graph equal 0? Well, when does a fraction equal 0? When the top equals 0. Okay, so let's set the top equal to 0. What are the roots of the top? X equals 1 and negative 2. Well, can those both be x-intercepts? No, because there's a hole at 1. So even if it tried to hit the x-axis at 1, it's going to skip over it. So the graph would look something like this. And you actually have to plug it in your calculator to figure out the shape exactly. So there's a lot going on here. How do you find the roots? You set the top equal to 0. How do you find the discontinuities? You set the bottom equal to 0. How do you find the horizontal asymptotes? You compare the degree of the top and the bottom. And all of this mixes together to create the graph of a rational function. Okay? So let's work a couple problems together. Let's do number 1. First off, does this have an HA? We check the degrees. The degree of the bottom is 2, and the degree of the top is 0. It's x to the 0. So the bottom is bigger than the top, so the HA x cannot be 0. Okay? Let's find the roots. Where does this graph hit the x-axis? Well, we set the top equal to 0. Set the top equal to 0. When is that true? When does 1 equal 0? Never, so this has no roots. Okay? So, again, don't let this word confuse you. Both of these are discontinuities. So by stating where the holes and the asymptotes are, you are stating the discontinuities. And I don't want to make you do it twice, even though the answer sheet has it twice. So I'm going to set the bottom equal to 0. Well, first I'm going to pull out a 3. X squared plus x minus 6. Does that factor? Factors of negative 6 that add to be 1. X minus 2 and x plus 3. So x is not allowed to be 2 and 3. And both of those happen to be, these are both vertical asymptotes. This graph has no holes. Is it negative? Oh, you're right. Negative 3. Thank you. Did that make sense? Okay, let's try another one. Number 4. So first, let's talk about horizontal asymptotes. What do you notice about the degree of the numerator and the denominator? They're the same. And again, the reason this works is we only care about what happens way out here and way out here. And here's a really weird thing. You can have a horizontal asymptote, and the graph can hit it a bunch of times, but at the end, it's getting closer. So a horizontal asymptote does not mean it never hits that point. It just means at the ends, that's where we're headed. And in fact, you can have a graph do this and keep alternating above and below the horizontal asymptote. That can happen. But in the end, where are we headed? So in this case, this degree matches that degree. So how do we find the horizontal asymptote? We look at the ratio of the coefficients, 1 over negative 4. So y equals negative 1/4. That is the horizontal asymptote. Now, does the graph pass through negative 1/4? It might. We'll have to look at our calculator to figure that out. Okay? Now we want to find the roots. How do you find the roots of a fraction? Set the top equal to 0. We just factored this a second ago. And we got x plus 3 and x minus 2. So the roots are negative 3 and 2 if they're not wholes. They might be wholes, so now we need to check the denominator. Negative 4 times x squared plus 4x plus 3. Okay. Does that factor? X plus 1 and x plus 3. Oh, what do you notice? So negative 3 we have to take off the roots list because x equals negative 3 is actually a whole. And then x equals negative 1 is a vertical asymptote. Okay, did I explain that in a way that it all kind of made sense? So I set this equal to 0. Negative 1 creates a 0 here, which makes the denominator 0. and it didn't cancel, so it has to be a vertical asymptote. All right, let's do some where we actually graph them. Take a look at number 5. So you might as well just factor everything to begin with, because you're going to have to do it at some point anyway. So negative 4 over x times x minus 3. First off, does this have a horizontal asymptote? The bottom degree is bigger than the top, so here is my vertical asymptote. Okay? Does this have any holes? Did any of the factors on bottom cancel? No. Does this have any roots? Oh, I'm sorry. You guys are so confused because I can't spell. Thank you. So where does this graph hit the x-axis? We set the top equal to 0, and there's no variation in there, so it can't happen. So there are no roots. And then we have vertical asymptotes at 0 and at 3. So x equals 0 and 3 are both vertical asymptotes. So now I need to graph it to figure out where exactly this happens. So negative 4 divided by x squared minus 3x. And you'll see exactly where to put the graphs. So like this, and like this, and like this. And asymptotes sort of work like roots. When we have a double root, how is that represented on the graph? It bounces. A double asymptote, for instance, if you had something like 1 over x plus 2 and x plus 2, that has a double vertical asymptote at negative 2. So at negative 2, the graph is actually going to be going in the same direction. So if an asymptote is approached by both sides in the same direction, it has an even number of roots, a 2 or a 4 or a 6 or an 8. But if the asymptote is approached in 2 different directions, then it happens an odd number of times, 1, 3, 5, 7, and so on. Okay, let's do number 7. So on top I have x plus 4. On bottom I have negative 2 times x plus 3. Does this have a horizontal asymptote? Yes, because when I divide the first terms, the x's cancel because their degrees are the same, and I end up with negative 1/2. So here is my horizontal asymptote, y equals negative 1/2. Okay. Does this have any roots? I set the numerator equal to 0, and I get x equals negative 4. So it touches the graph here at negative 4. So x equals negative 4 is my only root. And does this have any holes? No, but it does have a vertical asymptote at x equals negative 3. So right here is a vertical asymptote. Now, I can already guess what the graph is going to look like. It has to hit this point, so it's going to look like this. And how many times does that vertical asymptote happen? Once, which is an odd number, so the graph has to approach it on the other side. So it's going to look like this. And I don't even need to graph it. In fact, this one would be really hard to see, because all you're going to see is that and something like that. Okay? Number 8. Where is the horizontal asymptote in this case? Oh, careful. What happens when I simplify the two first terms? I get x over 3, which is the graph of a straight line with a slope of 1/3. The degree of the top is bigger than the degree of the bottom, which means it doesn't have a horizontal asymptote. It's a slanted asymptote. And this paper's not asking for that. So this has no horizontal asymptote. Okay? Let's factor the top. X times x squared minus 9. Does that factor further? X times x minus 3 and x plus 3. Right? So what are the roots? So the roots are x equals plus or minus 3 and 0. So we can go on the graph negative 3, 0, and positive 3. And then I'm going to pull a 3 out of the bottom, x squared minus 2x plus or minus 3. Does that factor? It's 3 times x minus 3 and x plus 1. Do you notice the problem? This cancels that, which eliminates. The plus 3 is now a whole. It's not a root. Okay, and we have a vertical asymptote at x equals negative 1. So let me get rid of these. So at negative 1, I have a vertical asymptote. So let's graph. You might as well just graph the original instead of having to multiply everything back together. So x to the third minus 9x divided by 3x squared minus 6x minus 9. And we should see a slanted asymptote in here somewhere. There it is. So the slope of that asymptote is 1/3, which is what we got from dividing the first two terms. So like this and like that. Get the hang of this? The vertical asymptote is found by any factor in the denominator that doesn't cancel. So in the denominator, I had 3 times x minus 3 and x plus 1. This canceled that, which represents a whole. Oh, we need to put that back in. So at 3, thanks for reminding me, make sure you put that whole at 3. Notice, no, the x minus 3 canceled, so x is not allowed to be 3 as the root. And notice, the root doesn't actually have to, or the whole isn't necessarily plugged where the root would be. If you look at x equals 3, it doesn't skip over the x-axis. It skips over a point higher. If I plug in 3 into the graph, I get nothing. So you don't see holes on the graph. So you need to put them back in. You need to draw them on your graph when you do. Okay? Any other questions? You want to do another one? Okay. Nice try. Let's do, which one you want to do? 10. Okay, number 10. So this is x times x squared minus 16. This is just like the one we just did. So x times x minus 4 and x plus 4. And then I'm going to pull a negative 4 out of there. Negative 4 times x squared minus x minus 6. Does that factor? Negative 4 times x minus 3 and x plus 2. So this one does it have a horizontal asymptote? No, because if I divide those, I get x over negative 4, which is the graph of a slanted line. So if the top degree is bigger than the bottom degree, you have something other than a horizontal asymptote. If they match, if the top and bottom match, then whatever's left is the asymptote. If you end up with something like 3 over x, where's the horizontal asymptote? It's at 0, because there's no way for this top to equal 0. Okay? Does this have any roots? 0, 4, and negative 4. So you can put those on your graph. Does this have any holes? No, because none of the factors in the denominator cancel. The numerator. And does this have any vertical asymptotes? Negative 2 and 3 are both VAs. That help? Yeah, you want to do one with a hole? Let's do 12. Oh, no, that won't work. 12 doesn't have a hole. You know what? I've got the answer sheet. I'll find one that has a hole. Okay, number 13. To start off number 13, does it have a horizontal asymptote? Where? We divide the first two terms, and I end up with 2. So this is the horizontal asymptote. Y equals 2 is the HA. Okay? So I pull a 2 out of the top, x squared plus 5x plus 6. That factors into x plus 3 and x plus 2. Does the denominator factor? X plus 2 and x plus 1. So those cancel, which means x equals negative 2 is a whole. And my vertical asymptote is found at x equals negative 1. So if I go to negative 1, that is my vertical asymptote. And I know that the graph has roots where? Well, the only root would be what's left in the numerator when we set it equal to 0 and we get rid of the whole. So negative 3 here. Now, do I need to bother graphing this one? No, I have one point, so I know what one side looks like. It has to approach both asymptotes, so here and here. And then, where do I know how to put the second one? It's got to be the top right corner. Why isn't it the bottom right corner? If you look at how many times the vertical asymptote happens, it only happens once, which means that the ends have to go in opposite directions. If there were 2 x plus 1s in the denominator, then the bottom right side would have the graph in it. That's the only difference. So if right now, it's going to look like this. But if I put another x plus 1 in here, then it would look more like this. Although you would end up with, oh, that's actually what it would be. It would change, it would get a little bit closer to the asymptotes, but it would have that basic shape. But we forgot one thing, the hole. So we go back, and we have a hole at negative 2. So we go over here to negative 2, and we draw a circle right there, because it skips over that point. Okay? No. I'll come help you.